today we're going to talk about lymphoid tissue inducer cells and the role of lymphotoxin production by those cells on stromal cells or dendritic cells. And Jana, and it does involve CXCL5, CXCL13. You know, some of the molecules you said. Jana has a project related to that. She has some inspiring ideas.
Maybe not really do something about lymphotoxin. That's not my focus, but I really got inspired from him that how the B cells and T cells are important for maintenance of the FDC. And as he just said, the stromal cells in the T cell germs is critical for the T cell survival here.
Right.
And then he said the FDC is actually located in the germinal center. So I think many people said that FDC is actually stromal cells originate from the stromal cells. So I think these two kind of cells may be just similar. They just stromal cells. And for my models, I think the T cells in the T cell germ, which might be pre-activated by the stromal cells, which might trap the antigen or something else, and then the pre-activated T cells might be attracted by the CXCL13 produced by the FDC, and then travel into the follicles to form the future germinal center.
So you're saying the T cell, or is this is the TFH precursor?
Yeah.
Like you said.
Yeah. Just have the idea.
And interacting with the stromal cells critical.
Yeah.
But is it through lymphotoxin? Do these produce something on this, like lymphotoxin beta?
It should be. I think that's an old concept that the T cells and the stromal cells will maintain with each other, support with each other.
Through this molecule, right? It is a support of the stromal cell. But I thought he said the T cell lymphotoxin beta is not essential for the T cell supportive stromal cell. So maybe it's lymphotoxin beta, maybe it's alpha or something else. But you're right in that maybe the T cells do support the stromal cells, and the B cells do support the FDCs, and the other way around, both ways. And this may be mediated through lymphotoxin beta, this may be through that or some other cytokines. That'd be something to think about. But then, in your case, the T cells progress along. Your first step was they express CXCR5, right? I remember your model, CXCR5.
Yeah.
And then, which is down here, the TFH, and then they respond to CXCL13 signaling by the FDC. So they're really up here, down here. They're not here. They're interacting with FDC. Okay, they go from here first, maybe from the T cells on the stroma, but then they switch their allegiance to TFH precursors, which are now talking more to FDCs.
Yeah. So these the T cells in the T cell germs, which may also help the B cells for antibody producing. That should be called extra follicular T helper cells or something. That will promote the short-lived antibody production. And then with the chemical from FDC, the activate T cells might migrate into the follicles, and at the same time the B cells come in, and then they form their germinal center for the long-lived antibody production.
Yeah, actually we just said that. I thought of something. Just like this model of infection, lymphotoxin, lymphoid tissue inducer cell comes in, stimulates the stroma, which produces the chemokine that then brings in the cell that clears up the infection, neutrophil. So the same thing, let's say the same thing like here, MZP B cell, which does B cell definitely produce lymphotoxin. They come in, they touch the FDC, then that induces CXCL13, the chemokine. That brings in the TFH, and then that promotes development. Notice the neutrophil as an effector cell it's sort of like, I don't know what it does, you know, it clears bacteria. The TFH comes in, it's slightly different, but it's not supporting this. This is supporting that. But this pulls this in, and this, you know, supports this, you know, it supports the B cell. So it's a bit here, support this, then pull this in and support that, which then supports that. So it's a cycle, a 3-cell cycle of support through different molecules. Like this molecule is, the main molecule here is ROT, TFH production of ROT, IL-21.
Which
Right.
is the critical cytokine for the survival of B cells and the like somatic augmentation
Right.
for the antibody production.
So it's lymphotoxin beta, CXCL13, and IL-21. Those three in a cycle.
Well, many old papers already say that the development and maturation of LTC do needs the help from B cells.
Right.
So maybe, but they didn't say what kind of factor contribute to that. So maybe that's the lymphotoxin.
Do you know if that needs antigen or just B cell?
They just say B cells.
They're all here, and then if you give them an antigen, then they form a germinal center. Yeah. In our case, you know, you get all the components there developed, ready to respond to an antigen, and that may make it even more exciting because then you get a germinal center, you know, which is very exciting, kind of a focused process. This is critical for a germinal center. So maybe they're all there, but then the antigen, this is there, kind of close at least. B cells are there, T cells are close, TFHs are at least there in some form. But the antigen touches something off. I think the antigen touches off, I don't know whether it touches off the FDC and the CXCL13. We talked about this, what's the first thing? We thought, you know, the CXCL13 was the first thing. But maybe lymphotoxin is it, because that would, if that was there, because we never know what this does, the B cell does, right? You don't know what it.
Yeah, so we don't know whether that CXCL13 production is induced by B cell bringing antigen.
This thing, CXCL13 could be dependent on lymphotoxin, beta, produced by the MGP and the FTC, then they produce CXCL13. Then they bring in TFH, CXL13 is that produces IL-21. So, man,
I don't know, but when I look at the FDC on the B6, which don't have the spontaneous germinal center, and we found that there many FDC there, and also we can see the CXL13 there, but not that much. I mean, the level is different from those in BXD2.
So you did measure CXCL13 in B6 FDC.
CXL13 in B6 and BD2.
It doesn't produce as much as the BXD2.
When we compare the level, the staining intensity, it's not as high as in BD2.
Oh, that's very interesting.
So I think it's very hard to see which one is the first step for this street party.
Yeah. But I like this thing here, because before we were talking about the antigen, delivering of the antigen, but if there's a nice cytokine focus, the question is, do MZPs produce high levels of LT beta?
Yeah, we could check that easily.
Yeah, we can check that. Okay, that's great.
You can just look at the RNA level.
Right.
Yeah.
Isolated MGP.
Yeah.
And then I also have a question here. So he just asked whether the IL-17 will upregulate the expression of 6alpha here.
Or
I
lymphotoxin.
don't know much about the B cells, but when I look at the T cells, I use the IL-17 to stimulate the T cells, and I found that IL-17 actually downregulate the expression of 6alpha. So it's kind of consistent with this one.
Yeah, that makes sense. If you upregulate an inhibitor like this, it could be, well, I don't know what really downregulated, but it's 6 or 5%. Okay, that's good. I think we got a lot of new ideas here.
Okay, thank you.
Okay, thanks.